home. There's only 4 apparently today, so that's going well. Oh, it's not plugged into this. Look at that again. All right. Oh, I was calling Vaughn. Flynn! Flynn, you with me? Yeah. All right, Flynn, what's a line tangent?
It's a line, like on a curve, to estimate the slope on it.
Line, to estimate the slope, it touches it at the point and has the same slope as the slope would have. If that's a bad phrase. You agree with it?
Yeah.
All right. Everybody else understand that idea? It's that thing we were dealing with at the very beginning when we wanted to estimate the slope. We drew a curve. If I wanted to find the slope here, I drew a line tangent to it at that point. Is that okay? Sorry, what? So the line tangent, what's a line tangent, Flynn?
It's like the line that you draw to estimate the slope at that point.
It touches at one point, the point of interest, right? And has the same slope, or derivative in this case. So, if we want to find the equation for a line tangent, oddly enough, we now have the skills to do it. What do we need to find the equation for a line? We need a slope and a point. In order for me to draw a line tangent, I have to tell you what point I'm interested in, so that's easy. How do I find the slope, Mr. Paulos? Be really loud. How do I find the slope of a curve? At this point, you should be like, oh, I get it. Find the derivative. Say that louder so that people at home can hear it. Find the derivative at that point, right? So we're going to find the derivatives, put the point in, to figure out where the slope is at that point. We want a slope and a point, and we know how to do it with a slope and a point, don't we? So let's do this.
And that's how we find the line tangent.
That's how you find the equation for a line tangent. Or how do you find them? Are you ready? Let's do an example problem. F of x equals 2x squared plus 1, and I want to find it at x equals 2. I always tell you where I'm going to find it. That can't be a surprise. It's not allowed to be. Mr. Reber, tell me what my point is that I'm going to find this at. X equals 2, but I usually need a y value for a point. How am I going to get my y value? Plug 2 back in. Actually, oddly enough, that's the hardest part of this problem. People forget this part. Like, well, how do I get a y? I get back in the original equation, right? Okay, so f of 2 would be equal to 2 squared plus 1. That gives me 9. So the point of interest is 2, 9. Mr. Sneerly, how am I going to find the slope? Find the derivative. First of all, what's the derivative?
4x.
And then I want to find it where? At x equals 2. Well, 2, 9, but x equals 2, right? 4 times 2, which is equal to 8. So now, how do I write an equation for a line? I'm going to go back to Algebra 1 for most of you. Some of you did this in 8th grade math, which you guys probably took in 3rd grade. But the way we find the equation for a line is we write y equals mx plus v. We know the slope is now 8. How do I find b? Do you remember, Jenkins? We plug the point we know in, right? That has to work. That 0.29 has to be on my line, right? So if I plug in 2 for x and 9 for y, I can solve for what b is. That make sense? Good. So 9 equals 8 times 2 plus b. And therefore, 9 equals 16 plus b, or b equals -7. So y equals 8x minus 7 would be a line tangent. Now, if this process works, we can check it by my eyeball on a graphing calculator. Mr. Davila, can you tell us how we might do that? Check to see if my line tangent actually is a line tangent by using my eyeball. Well, draw the curve, make the calculator draw my curve. What else would I do? Plug this into it as well. And then it should look like, at 2, it should be a line tangent. It should look just like a line tangent, right? So if I did it right, it'll look exactly right. Make sense? So if you want to check your answers, that's how you check your answers if I allow you to have a calculator in your desk. Read, make sense? All right, beautiful. Let's move forward. Let's do practice problems. Try to find the slope of a graph. Find the slope of a tangent line to the graph. Well, that's too easy. You know, actually find the whole tangent line. Let's find the slope of a tangent line for g of x equals. Try to find that slope of the tangent line. Do 2/3 x squared minus 1/6 x. That's the first thing I would do. So I recognize that the polynomial I'm allowed to do it. Then I just go ahead and g-prime it. And then I want to find it at what point? -1 is the only part that matters, but I'll write down the whole point. -1 is 5/6, so I put a -1 in there. Oh no, I have to do some fractions. Leaving it on. Put it back off. That gives me 3 times -1 squared. It's going to give me just 3, agreed? Yeah. All right. So now I have my slope and I have a point. How do I, yes, sir?
I'm confused how you got like 3x squared.
Well, what do you do when you take the derivative of a polynomial? Well, how do you do that? Well, we spent the last 2 class periods doing something called the power rule. And the power rule says I can take the derivative of this simply by throwing the number out in front on top of the x, the power in the x, out in front, reducing its power by 1. So I threw its power out front and reduced the power by 1. You should have done about 20 of these problems so far. Yeah?
Yeah.
You know what I'm talking about?
Yeah, I was kind of confused when there was nothing in front of the x. Now I get it.
Okay. Oh, so okay, that's fine. As long as that's the problem. Good. You're good?
Yeah.
Seriously? Okay. All right, good. All right, and then so I go y equals mx plus b. I know y equals 3x plus b is my equation for my line. Now I need to plug in the point. So I'm going to plug in my point. Negative 2 equals 3 times negative 1 plus b. Negative 2 equals negative 3 plus b. B equals 1. So my equation would be y equals 3x plus 1. This is solved. Does that make sense? All right. One other thing, and I hesitate to mention this because you guys weren't trained to do it this way. But if you were, or if you are into shortcuts and willing to memorize something new to do it, there is a quicker way to do this equation thing for the line. If you remember, slope equals y2 minus y1 over x2 minus x1. That has to be true for all things in the same line, agreed? So if I move this over, I get mx2 minus x1 equals y2 minus y1, agreed? With a little bit of cleverness, you realize, well, this could be any x and this could be any y. So the quick way to do this is 3 times x minus, what was x value? X value is negative 1. Equals y2 minus y1, which would be y minus negative 2. And you're done. That's an equation for a line. You write 3x plus 1 equals y plus 2, and they allow that as an equation for a line. All right? Now that said, you guys weren't asked to do that much. You have to do that a little bit in 9th grade or 8th grade, whatever it was. If you don't want to do that, you never have to do that. It's just a quicker way to do the same thing. Okay? All right. With that in mind, you should be able to go through the last two. Go! For realsies. Maybe 3. And 2 of them I never want to use. Formal definition and estimating by using points getting closer together. What I really want to use is the power rule at all times, correct?
Yeah.
So, the reason why I can't use the power rule is this is not a polynomial. So turn it into one.
Well, I thought that we would put x to the negative 2 power. To the top, to the numerator.
That would work. Now, I'm going to do that right now, but I want people not to get too tense because there's a more natural way to do this problem, but let's do it the way you just said. That is, I'm going to take my x to the second power and put it on top, so it makes it x to the negative 2, agreed? Once I do that, I can use the distributive property to get it down to a polynomial. Base is the same, so I add the exponents. 3 plus negative 2 is just 1, right? And negative 1 times x to the negative 2 is just x to the negative 2. Now I'm ready to go. Now that's just one way to do it. The other way to do it is to use your old school way you would think about doing, which is, I'm just dividing this, right? So just divide it out of both of these. So that would be 2x to the third minus x to the second, which is going to give me x, minus 1 over x squared, which I would then turn into this and be in the exact same place. Either one of those are fine. I don't care which way you do it. Whichever is better for you is the way you should do that problem. All right, you can take it from there?
I think so.
All right.
We will substitute 1 into the equation.
We got to take the derivative first.
Right.
Our point of this class is doing the algebra before you even take the derivative, right?
Yeah.
So my derivative at 1 would be
3.
no. All right, try number 2. We're doing time-wise.